The company sells tins of sardines. The weights of sardines are normally distributed. Now it's quite important they say that it's normally distributed with a mean of 30 grams and a standard deviation of 5 grams. Each tin contains four randomly selected sardines. So the distribution of total weights of fish in a tin. Well, if you have a variable called x, which is normally distributed, as I've explained before, with mu and sigma squared, so we'll call it mu1 and sigma 1 squared. If you want a variable y, for example, and in this case y is going to be 4 lots of this, then y can actually be normally distributed as mu1 plus your second mean plus your third mean plus your fourth mean, with your standard deviation squared for the first one plus your standard deviation squared, so your variance, 2, and so on and so forth squared. I can't write it today. So that would be effectively what your distribution would look like if you're adding loads together. Now these happen to be all exactly the same, so actually what I'm going to end up with is y being normally distributed, where y is the number of tins, so we'll call x f for fish, and we'll call y t for tins. So in a tin there's 4 fish, so I should have t being normally distributed with 30 plus 30 plus 30 plus 30, 120, and then it's now standard deviation, so my variance is going to be 25 because it's 5 squared, so 25 plus 25 plus 25 plus 25, which is 100. So the distribution of the total weight of fish will look like that, with a mean of 120 and a variance of 100. It then says the distribution of the mean weights of sardines in a tin. Now it doesn't mean the actual sardines in the tin, it means the mean weights of the sardines in the tin. And what we're trying to do is the distribution of samplings and see what that is. So here we've got individuals, and now what we're looking at is what is the mean of the sardines in the tin. So we're looking for, as indeed I can't even think at the moment, the chapter's called, basically we're looking at the distribution of the sample means. So we've currently got t being normally distributed with that and that. Now I know, for example, that the number of fish in a tin is 4 times the number of fish, so that's my relationship between the two variables. And so if I want to find out, for example, the mean number of tins, that should be 4 times the mean of fish. And if I want to find out, we're just using coding, which we did in chapter 1 of Stats 1, if I want to find out the standard deviation of tins, well, that will just be 4 times the standard deviation of fish. Now obviously we're dealing with variance, so the variance of tins is going to be the square of that, so it's going to be the square of all of this, which is 16 times the variance of the fish. Now we don't actually yet know what the variance of the fish is and the mean of those, but we do know that, like I said, there's 4 fish in a tin, so if I've got my distribution of tins up here, then the distribution of the mean weights of sardines in the tin will have a mean of 120 over 4, so that's 30 grams. However, the distribution of the mean weights of the sardines will have a standard deviation, and the standard deviation will end up being either this relationship, or I could use this relationship. Now I'm going to use the first one primarily because my variance is 100, so if I square root that, that gives me here the standard deviation of t being 10. So the standard deviation of fishes is going to be 10 over 4, which is 2.5 grams. Now you have to look at the previous video to remember to think about why this one is going to be different to this one up here. So watch the first video if you haven't already.